All right, now that you guys have this factoring down, we're going to add a little bit of a complication. We're going to turn it into an equation. So we're going to still have the trinomial or binomial, which we need to make sure is written in standard form. So standard form means that all of the terms are on one side and you have a 0 on the other side. Now, it doesn't matter which side, but you have to have all the terms on one side and a 0 on the other side. At that point, you're going to factor the polynomial. Once you factor the polynomial, you're going to have the two pieces or more on one side and 0 on the other. So what we're going to use is the rule that tells us that in order for us to take two factors and multiply them together to get 0, either one or the other would have to be 0. So either the binomial here would have to equal 0, or the binomial over here would have to equal 0. And so what we're going to do is we're going to set each of them equal to 0 to find our solutions. So this is really important. When we are looking at data, this actually tells us where this function crosses the x-axis, and that's very important. When we start throwing in data and doing real-life problems, we want to know when a function crosses the x-axis, and this is going to give us that. All right, these are just some YouTube videos that will help you with the factoring if you're still having some trouble with the factoring. Also, you can always go to khanacademy.org and you can get not only videos with problems worked out, but you also can get sample problems that you can try. So we have lots of resources for you. All right, this problem says to solve the equation. So notice we now have the equal 0. This one's already set up for us. It's already in standard form that it has all of the terms on one side and 0 on the other, but it's also factored for us, which was really nice. So now we can use what we call the zero factor theorem. Because this is multiplication, right? By having the two sets of parentheses here side by side, it's multiplication. Well, if we have two numbers multiplied together that give us 0, then one or the other of them has to equal 0. Otherwise, we wouldn't get to 0. All right, so what we're going to do is we're going to take this first factor and we are going to set it equal to 0 and solve for x. So we get x plus 7 is equal to 0. If we move the 7 over to the other side, we get that x is equal to -7. On this side, same thing. We're going to set this piece equal to 0 because we actually have two answers on this one. I'm going to show you in just a second. And so if we move the 14 over, we get -14. If we were to graph this, this is actually a parabola. You graphed parabolas already. And the parabola would sit over here. And so what would happen is this point right here would be -7. And this point right here, so these are both the x-intercepts, would be -14. So it's important that we know when the function crosses the x-axis, and this is a great way of finding that. All right, so when we come back up here for our answer, we are going to answer -14, -7. Now, technically, order doesn't matter, but in my brain it does because I need it to be in numerical order. But we're going to put a comma in between the solutions. Right, again, it says solve the equation. All of the terms are on one side and we have 0 on the other side. That's a must. We always want to check for that first. And this one's actually factored for us already. This one looks a little strange. I wanted to show you. Sometimes we have an x sitting out in front of the factored binomials, and that's okay. What we're going to do is, again, use that zero factor theorem, but we only have x, and so we're going to set x equal to 0. That's going to be one of our solutions. Over here, we're going to set x plus 2 equal to 0, and that would give us -2. So again, we have two answers, and we have to put both of those answers into our answer block here. So for this function, it's going to cross the x-axis at -2 and 0. So those are our solutions. All right, again, we're going to solve the equation. They have already put it in standard form and factored for us. They didn't factor completely, though, because we can see that they could have brought another 6 out of the first binomial. They could have brought a 4 out of the second, but they didn't, so let's just work with what they gave us. It's already factored, so we can take each term and set it equal to 0. We're just going to do a little bit more work. So we have 6x minus 6 is equal to 0. If I move the 6 over, we get 6x equals 6. And then if I divide both sides by 6, I would get positive 1. All right, on the other side, we have 8x plus 4 equals 0. So move the 4 over, we get negative 4. And then divide both sides by 8. Well, when we divide both sides by 8, we get negative 4 over 8, but that is not simplified. And so we're going to change that to negative 1 over 2. So we sometimes do get fractions. That's okay. We get fractions, decimals. In real life, functions don't cross at nice tick marks like we make them do in class. And so again, we have two answers here. We have negative 1/2 and we have positive 1. And therefore, both of those are solutions. Both of those are where we cross the x-axis. All right, instructions say solve the equation. We have x squared minus 12x plus 32 equals 0. So we're in standard form. All of the terms are on one side. We have a 0 on the other, but they didn't factor this one for us. So let's go ahead and factor. We need to break down the 32. So we could have 1 times 32, 2 times 16, 4 times 8. What else do we have? I think that might be it. So we need, so these are all the factors that would give us 32, but we need to sum to 12. So we want 4 and 8. However, we have a negative 12. So we want negative 4 and negative 8. So let's come up here. And because we have a 1 in front here, we don't have to do the box method and the AC method. We can actually just put x minus 4 and x minus 8 in. Now let's go ahead and just check our work. If we FOIL, we have x times x gets us x squared. We have negative 8x as our outer and negative 4x as our inner terms. If we add those together, we get the negative 12x in the middle. And then negative 4 times negative 8 gives me the 32. So I'm good to go. I factored, right? We need to factor. And now I can set each of these equal to 0. So I have x minus 4 equals 0, or x equal positive 4. And then here I have x minus 8 equals 0 and x equal 8. Now you've probably noticed by now that the sign just changes, right? And so you don't have to write all this. You can eyeball it and see that if you have x minus 4 is equal to 0, that's going to give you a positive 4. If you have x minus 8 equal to 0, that's going to give you a positive 8. So those are my solutions, 4, 8. And we are good to go. All right, once again, we're solving. They were nice enough to put all the terms on one side for us and a 0 on the other, but now we need to factor. So let's come down. We need factors of negative 8. So we could have 1 times negative 8, negative 1 times 8, 2 times negative 4, or negative 2 times positive 4. I think that's it. So we want to now add these together and get a positive 2. So if we add 1 and negative 8, we get negative 7. Negative 1 and 8, we get positive 7. 2 plus negative 4 gets us 2, but it gets us a negative 2. So we want negative 2 and positive 4. If we multiply them together, we get the negative 8. If we add them together, we get the 2 in the middle. Now, because I have a 1 in front of the x squared, I don't have to do a box or an AC method. I could just pop these right in. I'm going to put the 4 first. It does not matter, the order. I like to have my smallest term first, but either way, we could have done x minus 2 times x plus 4, because remember it's multiplication, so order doesn't matter. All right, so now I'm going to set these equal to 0. So I get negative 4 here. And then here, x minus 2 equals 0. I get positive 2. So these are my solutions. This is where I cross the x-axis. Also, if I took any of these solutions and put them back into the original problem, I would get 0. All right. Okay, here's the first one that is not in standard form. We do not have 0 on one side, we have 40, and so we cannot start factoring. We have to move that 40 over to the other side, and then we can start factoring. Looks like I did not write the problem right. This is negative 6x. I apologize for that. All right, so let's go ahead and move the 40 over. Of course, when it moves over, it changes signs, which is very important. So I now have x squared minus 6x minus 40 is equal to 0. So now I'm in standard form, and now I can go ahead and factor. So let's see, we have negative 40. We know the bigger number needs to be negative because I have a negative here. So let's see, I have 1 times negative 40, 2 times negative 20, 4 times negative 10. Looks like that one's going to work because 4 times negative 10 gives me negative 40, and 4 plus negative 10 gives me the negative 6 in the middle. All right, so we have x plus 4 and x minus 10 is equal to 0. Now, I'm going to just check my work really quick. So x times x gives me x squared. I'm going to FOIL. X times negative 10 is negative 10x. That's my outer. The inner is 4 times x. So those are like terms. So negative 10x plus 4x gives me the negative 6x that I need. And then finally, my last, I've got 4 times negative 10 is negative 40. All right, but I'm not done. I factored. This is why we practice factoring. I factored, but now I need to set each of these equal to 0 and get my solutions. So I have negative 4 and positive 10. All right, that's it for part 1. Let's move on to part 2.